Have you ever looked at a math problem, one packed with letters, and felt like you're just staring at some top-secret code? Well, welcome to this explainer. Today, we're basically becoming math detectives. We're going to learn exactly how to translate real-world mysteries into mathematical code. If you've ever wondered how on earth we use numbers and letters to solve everyday physical problems, you are definitely in the right place. We're breaking down the absolute core concepts of sixth-grade equations and inequalities. And honestly, by the end of this, you'll see that math is really just a language we use to describe the entire world around us. Okay, let's dive right in.
Here is our exact roadmap for the investigation today. 1. Meet the mathematical unknowns. 2. Solving one-step equations. 3. Real-world math applications. 4. Understanding mathematical inequalities. And 5. Independent and dependent variables.
All right, starting off with Section 1, Meet the mathematical unknowns.
To start cracking this code, we first need to identify the core of our mystery, the variable. And we do this using an equation. You can think of an equation as, well, a perfectly balanced scale. On one side, you have certain values, and on the other, you have values that are exactly equal to that first side. Our main objective as investigators here is to expose the true value of that hidden variable so our scale stays perfectly balanced.
Picture a tall X tile. That right there is our unknown mystery. It's sitting alongside our known constants, like a regular 1 tile. When we look at an equation, our ultimate goal is to figure out exactly how many of those 1 tiles it takes to equal the exact value of that X tile. It's really that simple.
Moving on to Section 2, Solving One-Step Equations.
So now that we've identified the suspects, our variables, let's open up the detective's toolkit to actually solve the case. We're going to solve these equations in one clean step. First, you identify the operation happening to the variable. Is it being added, subtracted, multiplied, divided? Once you know that, you use what we call inverse operations. This simply means doing the exact mathematical opposite, like say using division to completely undo multiplication, to strip away those known numbers and expose the variable all by itself. And finally, like any good detective, you always check your work by plugging your answer right back into the original equation.
To really picture this in action, think about it like this. If our equation is adding a positive 1 tile to our unknown x, our inverse tool is just bringing in a negative 1 tile. By throwing a negative 1 into the mix, we cancel out the positive 1 entirely. Poof, gone. The variable is totally isolated and, boom, the mystery is solved. It is all about doing the opposite to maintain that perfect balance. Which brings us to Section 3, Real-World Math Applications.
Now here's the really crucial point. We aren't just solving these puzzles in some theoretical vacuum. These mathematical codes actually reflect real physical constraints in our everyday lives. We use equation formats like x plus p equals q for addition problems or px equals q for multiplication to represent actual tangible constraints. Whether you're standing in the aisle calculating the total cost of your groceries or figuring out exactly how many more miles you need to drive on a road trip, you are using these exact precise equation formats.
Ultimately, equations and inequalities are really just the sentences we use to describe the world around us. And once you know how to write the sentence, you can solve the problem.
All right, Section 4, Understanding Mathematical Inequalities. Let's introduce a fun little twist to our investigation here. What happens when things aren't perfectly balanced and equal? I mean, not everything in life is an exact match, right? This is a massive narrative pivot for our mathematical mystery. Unlike a standard equation that gives us one exact specific answer, a single suspect, an inequality represents a condition. Forms like x is greater than c or x is less than c completely blow the door open. Instead of one single answer, these inequalities literally have infinitely many solutions.
Now, we obviously can't sit around writing out an infinite list of numbers, right? So we use number line diagrams. We plot our starting point, and then we just draw an arrow pointing endlessly in one direction to chart out the entire vast range of mathematical possibilities. We call this endless range the solution set. By isolating the variable with an inequality symbol, you're not just finding a single suspect anymore. Actually, scratch that. It's more like you're highlighting an entire neighborhood where the answer could live. Think of it like throwing darts. Any number that lands within that designated target set makes the entire mathematical statement completely true. And finally, Section 5, Independent and Dependent Variables.
So, what happens when multiple mathematical forces start interacting? When we track two quantities in a real-world problem, we start to see actual relationships form.
But to truly understand these relationships, we have to cleanly identify the independent variable, which is our fixed cause, and the dependent variable, which is the changing effect. The dependent variable relies entirely on whatever that independent variable happens to be doing.
Let's map this out with something we all know. Think about your job. The hours you work is the independent fixed variable. It directly dictates the changing effect, which is the total pay you earn. The exact same goes for shopping. The fixed number of items you toss into your cart absolutely dictates the dependent, changing total cost when you finally hit the checkout.
And here's the best part. Once we identify which variable is fixed and which one is changing, we have the power to trace their entire relationship. We can lay them out in tables, plot them out visually on graphs, and express them using the exact same equations we've been mastering today. It all connects, and it allows us to map out complex, constantly changing scenarios with surprisingly simple math.
As we wrap up this explainer, I have a challenge for you. Look at your own life off the screen. You now know exactly how to identify variables, balance equations using inverse operations, and map out infinite possibilities using inequalities. So I want you to ask yourself, what are the fixed causes and changing effects writing the equations of your own daily routines? Keep looking for those mathematical codes out in the real world. Thanks for learning with me today, and keep exploring.